Welcome back, guys, to Daily Maths Concepts. What we're looking at today is question 6 from the January 2020 paper 2 examinations, CXC. So let us see. It says, at a track meet, a cylindrical container fitted with a pipe as shown in the diagram below is used to serve water to athletes. The cylindrical container of radius 12 centimeters and height 20 centimeters is completely filled with water, and the pipe fitted at the bottom dispenses water into cone-shaped cups. The cone-shaped cups have a radius of 3 centimeters and a height of 8 centimeters. All right, there we go. First question says here we go. It says, calculate the volume of water in the cylindrical container in liters. All right, and write your answer correct to 2 decimal places. All right, so here we're getting that there is 1,000 centimeter cube that gives 1 liter. All right, let us go. Let us look back on the measurement, right? So the volume of the water in the cylindrical container simply means that we need to find the volume of the cylindrical container. But let's look on the measurement. Here is a container, all right? And in this container here, we have a radius of 12 and we have a height of 20. So with this information, we can just find the volume of this container because it is the area of the cross-section times the height, all right? And the cross-section is a circle. Volume of the cylinder, all right? So the volume of this cylinder is equal to pi r square h. So we're talking about so let's say we're using pi as 3.14, so 3.142. Pi r is 12 square times the height of 20. As long as we put that together, we'll definitely get the volume, a value of 9,048.96 cm cube. All right, so this is the amount of water that is in the cylinder in cm cube, but they don't want that. They want it in liter. So remember now, it's 1,000 cm cube give 1 liter. So we're going to divide this by 1,000. All right, so in dividing this by 1,000, our decimal point it will travel. So in liters, we're talking about 9.04896 liters. But guess what? They want this to 2 decimal places. So finally, the answer is 9.05 because we'll stop here and then this is 8. We round up to 5 liters. So that's our answer there, 9.05. That's the amount of liter that is being held in the container. Let's go. Part B says water flows from the cylindrical container along the pipe into the cone-shaped cups, right? At a rate of 7.8, talking about 7.8 milliliters per second. All right. So they want us now to calculate the time taken to fill 1 of the empty shaped cup. All right. So in order to find out, we need to get the volume of this cup. All right, so let's get the volume of this cup. 1 is here. So we have the volume of that is 1/3 pi r square h, right? So the cone has a radius of 3 and a height of 8. So let us go. So now, in terms of calculation, it's going to be 1/3 pi, which is 3.142, times r, which is 3 times 3 times 8. All right. We're going to find ourselves with 75.408. And this is cm cube. All right, 1,000 cm cube give me 1 liter. And then it takes me 1,000 milliliter to give me 1 liter as well. Then definitely you're seeing that there is a 1-to-1 between centimeter cube and milliliter. So it takes 1 centimeter cube to give me 1 milliliter. So we want to understand this idea right here, right now, as we go forward to solve this problem. The time in second, right? The time in second, all right, that is needed for it to be filled is going to equal to 75.408, and I want to divide this by the rate, right? I'm going to divide this by 7.8 because this is the same. So this that we're looking up here is the same as 7.8 cm cubed, right? So it's the same. All right, so because it's 1-to-1, 7.8 cm cubed is the same as 7.8 milliliters. All right, so it's running out. So we divide by that. So divide that by 7.8, 9.66769, and it goes on seconds. But remember that they do want it to the nearest second. So to the nearest second, we're talking about 10 seconds here. So in 10 seconds, we're going to fill one of those little cups. 10 seconds. All right. So we have 10 seconds here, right? So the last piece says, determine the number of empty cones, right? Empty cone-shaped cups that can be completely filled from this cylinder. Remember now that the cylinder has 9.05 liters, right? So we have 9 and this is in the cylinder, right? Whilst the cup, one of the cup is 7.408 cm cubed. So if I change this back to liter, so the 7, this is one of the cup cone shape cup. Talking about, all right, so for the cone shape cup, we're talking about 75.408, and this would have been cm cubed. So if we want to change this to liter, we divide by 1,000 so that we're in a common unit. So therefore, I'm going to divide this by 1,000 just to work in the same unit. So we're talking about 0.075408 liter. That is the capacity of the cup, all right? So we just divide this by 1,000 and we get that. So what we're going to do now is to see how many we could get out of this. So in a response to this, it's going to be 9.05, and we want to divide this by 0.075408. Let's see how many cups we could get out of that. 9.120.0. All right, so we're talking about 120 cone shape. Right, so there it is. It's 120 of these cups that we're definitely seeing that could have been filled from this. All right, thank you for watching. And if you think that you learned, you could subscribe to Daily Maths Concept on YouTube. Yes, thank you.